Hey guys, so in this video we're going to discuss water reabsorption in the nephron. So the first region we'll look at is the proximal tubule, and I'll highlight that right here in red. So in this proximal tubule, you'll notice that approximately 65% of the water that enters into the Bowman's capsule and gets processed or filtered gets reabsorbed. Now this makes sense when you realize that in this area we have constant reabsorption of sodium. So logically the water would follow osmotically. Now the next region is the loop of Henle. So the loop of Henle is made up of two parts. The first part is the descending tubule. So the descending tubule is permeable only to water. So in this region you have constant reabsorption of water. Now when you start to ascend, you have a region that is permeable only to ions. So in the descending portion, you're creating an increasingly hypertonic solution. Now when you can finally let those ions out in the ascending portion, the ions flow right out. And in this area, you end up getting a high concentration of ions as they flow out. And that's right next to the descending, and so that in turn pushes even more water out because the environment is now hypertonic relative to this area. So this is known as counter-current multiplication because you have two currents that are running counter to each other and their effect is multiplicative. Now, we'll look at the next region, which is the distal and collecting tubules. Now, these areas generally are not permeable to water, except for in the case of vasopressin. So vasopressin is able to act on these V2 receptors, and these V2 receptors are able to recruit more aquaporins. So these aquaporins, in turn, allow water to flow in through the the cellular lining of the tubules, and back out into the peritubular capillaries. And that is responsible for any reabsorption that occurs inside the descending and collecting ducts. Or I apologize, the distal tubule and the collecting duct, not the descending. Don't get those confused. Now the question is, what releases vasopressin? And vasopressin gets released its release gets stimulated via osmoreceptors in the hypothalamus. So you have osmoreceptors that are constantly checking the osmolarity of the body fluids or the plasma. And when it finds out that the osmolarity starts to get really high, so we have a hyperconcentration, then what ends up happening is it stimulates osmoreceptors in the hypothalamus, which stimulate the release of vasopressin, or ADH, antidiuretic hormone, from the posterior pituitary to the kidney via circulation. And when that occurs, we end up getting increased retention of water, and increased retention of water helps to dilute the plasma, and that solves the problem of high osmolarity next to the hypothalamus. And that's all for today, and if you have any questions or comments, let us know below. And if this was helpful, make sure to subscribe. Thanks.